Okay, welcome back everybody. So let's do some examples for the first part where we're going from mass to moles, okay? So the first question is let me zoom in on that portion of the board. Hold on one second. Let me zoom in. Okay, we have 5 grams of argon, right? AR stands for argon. How many moles of argon do we have? Again, you need to be able to understand what AR is, okay? So make sure you know your ions, make sure you know your ionic compound, make sure you know your atoms and their symbols and their names, okay? So 5 grams of argon, how many moles of argon do we have? So very simple calculation. Our given, okay, so again we're going from mass to moles. Our given is 5 grams, so we'll put the 5 grams first. So 5 grams of argon. Make sure you put the whole thing there. We're going to multiply that by the inverted molar mass. So look at that formula that I showed you. The inverted molar mass, so typically the mass of argon, if we look at the periodic table, here it is right here. Argon has a molar mass of 39.95 grams per mole. If it's inverted, we'll put 39.95 on the bottom grams of argon, right? And then 1 mole of argon on top. And that's all there is to it. Now you have to calculate it out. Again, best way to check if your answer is correct is make sure the units cancel out. The grams of, because we want the moles of argon at the end. We want the moles of argon at the end. That's what we want. Make sure your units cancel out, so the grams of argon and the grams of argon cancel out. The numbers don't cancel out, they're actually going to divide with each other, but the units are mostly important. The units, grams of argon and grams of argon, are going to cancel out, and we're going to be left off with our moles of argon on top, and that's what we want. That's the whole point of dimensional analysis, to get that unit that we want on top. And if we do our calculation, let me do this right quick in my calculator. So 5 divided by, okay, so 5 times 1, we can do the whole thing, divided by 39.95. The answer I got is 0.125 moles of argon. And if we want to worry about significant figures, we would have 1 in this case, so I'll put a little mark right underneath the first slide. And significant figures, we could talk about that later in another video. So that's all there is to calculating it out. Remember, we want to make sure that the units cancel out. Now let's just say, for example, I want to just show to you how important units are. If we were to flip this, where we have the regular molar mass where grams are on top and moles are on the bottom, that wouldn't cancel out with this, and we would just get this funky number that doesn't make sense. So that's why you have to make sure that units cancel out. Grams of argon and grams of argon cancel out, and you're left off with moles of argon on top. Whatever unit you want, for example in this case is moles of argon, it has to be on top, and that's how we get that answer. Let's look at the next example. Let's zoom out just a tad bit. Okay, example 2. We have 2.5 grams of sodium chloride. How many moles of sodium chloride do we have? Again, you see how ionic compounds, naming and knowing the chemical formulas are extremely important. Here's a case right now where we have to know how to make an ionic compound. I'm not going to go through the details of how do you know how to form that ionic compound, but because you can check that out in my video, and I put a link to it already. But nonetheless, sodium chloride is NaCl. Okay, and now that we have the chemical formula, which is extremely important when we're trying to do this calculation, now we could proceed with the calculation. So again, our given is the 2.5 grams, so we have 2.5 grams of NaCl, right? We have 2.5 grams of NaCl. Let me zoom in just a little bit. And then we're going to multiply it by the inverted molar mass, so grams of NaCl, right, over 1 mole of NaCl. But here's a problem. We don't know the molar mass of NaCl. How do we determine that? Typically for an element, we could just look at the periodic table. So for example, for sodium, we could look and it would be 22.99, and Cl would be 35.45, and we'll be like, we could just figure it out for one element. But now in this case we have 2 elements. It's pretty simple. All you have to do is look at the periodic table for each specific element. So for example, Cl has a molar mass of 35.45, right, grams per mole. Na has a molar mass of 22.99, and the numbers I'm getting right here is straight off from the periodic table, grams per mole. And all you have to do to get the molar mass of NaCl is sum the two masses together. You have one sodium, which translates to 22.99 grams per mole. We have one chlorine, which translates to 35.45 grams per mole. Add the two together and you get your molar mass for sodium chloride, for that ionic compound. Now, let's just say, for example, let's just say that the ionic compound, though this is not right, but let's just say, for conversation's sake, that there was a 2 here. We would multiply this number by 2 as well, because if we have 2 sodiums, we need to have twice that mass for the 2 sodiums to account for the 2 sodium. That's something to keep in mind, okay? So let me do this little quick addition. 22.99 plus 35.45, 58.44 grams per mole. That's the molar mass of sodium chloride. And now we do our calculation. 2.5 divided by 58.44 is equal to 0.0427, okay, 0.0427 moles of sodium chloride, NaCl. Let's make sure our units cancel out. So we left off with moles of sodium chloride on top, grams of sodium chloride, and grams of sodium chloride cancel out. We're left off with the moles of sodium chloride on top. And there we have our answer. Now, significant figure wise, it would be 2, so it would be that one right there. You would round that up to 0.043, but for this video, we're not really worried about that. I could talk about significant figures in another video. Final question, final example. Let me zoom out for the last portion of the video. Okay, we have 32 grams of magnesium hydroxide. How many moles of magnesium hydroxide do we have? First thing is first, we need to translate this into the chemical formula. So this will be MgOH2. If you don't know how I got that, check that video out, Ionic Compounds and Molecular Compounds, 5-part series, okay? Again, Mg, parentheses, OH2, that 2 is referring to the overall species. We have 2 OHs. So again, we're going to do the same little setup. We're going to put our given, so it'll be 32 grams of MgOH2, right? Multiply it by, zoom in just a tad bit now. Multiply it by the inverted molar mass, so it would be grams of MgOH2, 1 mole of MgOH2. We get our answer on the side to be moles of MgOH2. That's going to be our units for our answer, okay? So how do we figure out the molar mass of magnesium hydroxide? The same way we did for sodium chloride. The mass of magnesium from the periodic table, let's look at it. Magnesium would be right there, number 12, which has 24.31, right? Grams per mole. Now this is a little tricky case. We have this 2 here. That 2 designates something. It says that we have 2 hydroxides. So you could basically, it says we have 2 OH groups, that we have 2 OH species. So basically what we could do, which means exactly the same thing, is distribute this 2 to both the H and the oxygen, okay? We could distribute that 2 to the H and the oxygen. If we have 2 H's, it's the same way as saying that we have 2. If we have 2 OHs, it's the same way as saying we have 2 H's and 2 O's, okay? It's the exact same thing. It means the same thing. So we would have, for this guy, would be, for oxygen, I'll show you guys right here, it will be 16.00 times 2 to account for that 2 right there, right? And for hydrogen, it will be 1.004, I believe, 008 times 2 as well. Again, and this will be in grams per mole. So let's do this quick little calculation here. So it'll be 24.31 plus 32 for the oxygen, plus 1.008 times 2. I get a number that comes out to 32.00, right? That'll be 32.00, and 1.008 was going to be, I think it will be 2.016. Yeah, that looks right. And then sum all these numbers together. This 2.016 is 32 and the 24.31. Again, they're all grams per mole. Grams per mole. They're all in units of grams per mole. I can show you under the corner so you believe me. Sum all of them together, you get a total mass of 58, I believe. Double check this as well, guys. 58.326. That's the molar mass of magnesium hydroxide. Now we do our final part of the calculation, so it'll be 32 divided by our answer. I got 0.54 moles. 0.54 moles. And let's see, let me zoom out just a tad bit here. 0.548 moles. And if we want to talk about significant figures, we will round that 4 up to a 5. But then again, I'll talk about sig figs in a later part. So that's it. That's going from mass to moles. Now we're going to transition over from going from moles to mass. Alright, welcome everybody. In this part, I'll be discussing how to go from moles to mass. So moles to mass. And this will conclude this video on moles and Avogadro's number and the whole 9, okay? So again, here's some examples. For this case, I'll go over 2 examples because I think you guys got a good handle on this. First example, we have 3.2 moles of manganese. How many grams of manganese do we have? First things first, we need to be able to identify what manganese is. Manganese on the periodic table would be number 25, which stands for Mn, right there. So you guys have to know your chemical symbols and the words that correspond to them, okay? So you need to know that manganese is Mn and Mn is manganese, so make sure you know that. Flashcards is a must. So Mn, okay, and in this case, the general way of doing this, okay, zooming in just a little bit, we're going to put the given amount of moles. So we have 3.2 moles of Mn. We're going to multiply it by the molar mass. That's the way we do this typically. Moles of manganese is going to be on the bottom, right? And then we're going to have the grams of manganese, which is determined from the periodic table, on top. So how we could determine that is looking at the periodic table. Manganese is number 25. It has a molar mass of 54.94 grams per mole. 54.94 grams per mole. There you go. That's going to give you your answer. Let's calculate it out. 3.2 times 54.94 equals 175.808 grams of Mn. Okay, if we're talking about scientific notation, if we're talking about sig figs, it'll be that number right there. We'll round that one up, and then we'll have to translate this into scientific notation, but we're not really focusing on that, so the answer in this case would be 175.808. okay, there you have it. To make sure that the units cancel out, moles of manganese cancel out with moles of manganese, and we're left off with the grams of manganese, and that's what we get in our answer. Extremely important. Make sure your units cancel out, so way to double check your answer. The final question is, you have 1.5 moles of ammonium chloride. How many grams of ammonium chloride do we have? Let me zoom in on this portion of the board. Oh, that got blurry. I don't like that. Okay, hopefully this clears up. Come on, let's fix this. Okay, good. First thing you need to do is translate this into the chemical formula. Again, refer to my ionic compound video if you need help. So we have NH4Cl. That's the translation from the word to the chemical formula. So again, let's write it out. We write out the little formula that I showed you guys. We have given 1.5 moles of ammonium chloride, NH4Cl, right? We want to figure out the mass of ammonium chloride. So we're going to use the molar mass in this area. We're not going to invert it. We're just going to have it regular. So we'll have grams of NH4Cl on top. Then we're going to have 1 mole of NH4Cl on the bottom, right? Let me just make this a little bit more readable. NH4Cl, and then we're going to get our answer, grams of NH4Cl. Okay, so we have to figure out what the molar mass of ammonium chloride is. It's pretty straightforward. Nitrogen has a molar mass of 14.01, I believe. Hydrogen has a molar mass of 1.008. Since we have 4 hydrogens, we'll multiply that by 4. Chlorine has a molar mass of 35.45. I'll zoom in on the top portion so you guys can see those numbers. There you have it. We need to sum those guys up and multiply the number of hydrogens by its molar mass. So let's figure out this calculation. 14.01 plus 1.008 times 4 plus 35.45. I get a molar mass of 53.492. You guys should try this on your own too to make sure the calculations are consistent. Zoom out just a tad bit so we can see the overall formula. So all we're going to do is multiply 1.5 and 53.492. So 1.5 times answer. I get a mass of 80. My writing is getting horrible by the minute. So 80.23. If we were going to talk about sig figs, I would end it right there and we get an answer of 80 grams, but in this case we're not worried about sig figs, so our answer would be 80.23 grams of ammonium chloride. Okay, so let's make sure our units cancel out. Moles of ammonium chloride and moles of ammonium chloride cancel out. We're left off with grams of ammonium chloride. We're left off with grams of ammonium chloride on top, which is perfect. We get our answer. Okay, and there you have it. That is a nice brief but in-depth discussion about excuse me, my voice cracked, about moles and Avogadro's number, and hopefully that made sense. Feel free to ask questions in regards to this video. I'm sure there will be quite a few questions, and I'll do my best to get to you guys and answer your questions. And that's pretty much it. You know, I hope this made sense again, and thank you guys for watching, and this is MoBaller12 signing out.